Hello everyone. Welcome to week number 4, which is prompt design as well as output control for large language model. So by far till date, what we have learned is that we went through the different topics of deep learning. We went about transfer learning, transformers, attention. Today we shift from understanding how model works internally to understand how we can interact with it more reliably. And the goal is not to just learn how to design better prompts, but we will treat prompting as a systematic design. We will learn how instructions, context, and examples and the output modify as soon as you give different kinds of prompts. So by the end of this lecture, you should be able to create prompts which are more specific, testable, as well as suitable. So till date, if you have seen that there are these two terms, which is prompt design as well as output control. So prompt design refers to how we structure an instruction so that the model understands the task, the information that we are feeding in, and the expected response. Output control, on the other hand, refers to how we constrain the form, the length, the style, and the content of that particular response. So by far, if you know that we have went through the different weeks, and by week, we understood initially we started with the foundations, then we moved towards deep learning and transfer learning, then we went about transformers, and this week, we are particularly focusing on LLM prompting, where we are moving from model architecture to model interaction. And we will learn how to translate a task into an instruction that the model can follow with greater consistency. In the consecutive weeks, we will be learning about retrieval augmented generation, which helps us place relevant any external information into the model's context. Week 6, we will move towards responsible AI and then AI security, because security plays an important role whenever there are malicious actors who can make the model deceptive in a way that it can start giving you wrong information. And finally, you will end with your week number 8, which is your final project. Now, moving towards this particular week, there are 3 major objectives that we would be having. The first is to construct prompts that improve task performance as well as output control. This is the main focus for today. The second objective is to classify common LLM failures. And the failures are basically, we will be discussing about hallucination and instruction drift. So hallucination occurs when the model produces unsupported or fabricated content. So that is one aspect. Instruction drift is another one, which is where the model gradually stops following the original requirements. So it loses whatever has been asked by the user, and it starts giving you a totally different outputs. It's trying to drift from the original user query. And the third objective that we will be focusing in this week is critique. Critique tool use and agentic workflows for which are suitable for a given problem. So an agentic workflow involve that what should be a perfect model selection, where it can perform multiple steps in order to give an autonomous learning objective, whatever the task that you are giving to the model. And these workflows that you design can be useful, but they also introduce failure points and evaluation requirements. So for today, we will be focusing on, as I mentioned, the construction as well as the output control, how you can control the output. So as you have seen that why we are moving towards development of an AI system which can generate information. So if you know that last week when we started discussing about transformer is a model that predicts the next token from the available context using this a beautiful phenomena which is called as attention. And during pre-training, the model learns broad statistical patterns from very large, humongous amount of data set. And this gives it substantial language competence, but a raw pre-trained model is fundamentally a text continuation process. You continue the text. A raw next token model does not automatically interpret every input as a user interaction. And to create an AI assistant or an AI bot, developers typically apply instruction tuning. And instruction tuning is the way the model is fine-tuned in a way of pair the instruction as well as the response pair, so that um, you can the model understand that what should be the appropriate response for a particular instruction. So this teaches the model to recognize the input as a task to complete rather than merely text to continue. And that's what the difference is between from the transformer to an AI assistant system. There are various preference alignment model, and particularly which is reinforcement learning with human feedback, where the feedback is given by a human and the model learns. There is a reward mechanism wherever the model is giving good amount of output, the human provides a positive reinforcement, otherwise there's a negative reinforcement. Recently there are other preference models also that have been designed, which is the DPO, direct preference optimization, which shape the behavior of the model. And these models encourage responses that people judged to be more helpful, safe, honest, and aligned, because they are particularly designed or the reinforcement is done by the human in this. So the prompt becomes this, it's an interface between the user as well as the AI assistant that you are interacting. And we are not only changing the model's weights each time we ask a question, instead we influence the behavior through the information that we are placing in the context window. So the instructions that we are feeding, the source material, all the prior conversation, all of them affect the output. And this week is about how we can design these better prompts in general. So there are these four important things that we should remember in order to create the strong prompt, which I have abbreviated as R, C, F, and E. So R stands for role and task. So the role gives the model a useful perspective, such as I can provide a role saying that act as a cybersecurity instructor, or act as a person who is giving the temperature weather forecast, or act as a technical editor. So this is kind of giving the role to the large language model to behave in a particular manner. The second important thing which plays an important role when you are designing the prompt is the task. You should be giving a clear-cut task, whether that task is summarization, classification, comparing, extracting, or rewriting. If you're not providing the task, the model doesn't know and it starts producing wrong information. So role is helpful when it adds relevant constraint, and the task is important so that it knows what exactly needs to be done. So that stands for the very first important part, that when you are designing this wonderful prompt, which is R. The next one stands as context. Context include the text, the definition, the audience information, what are the assumptions, the grading criteria, the constraints, whatever you are giving. So the model can only use that information it has learned or information that you are providing. And that is the reason context plays an important role whenever you are giving. I will give you an example in the consecutive slide. Maybe that way you will be able to understand. The next part is the format. You need to provide how exactly you are expecting the model should produce the output, whether it is in the form of a table, whether it is in the form of just text, or it is in the form of an image with the vision large language model, or something else. So the format does play an important role. If you do not, then it will just produce bunch of data. The next one is the examples. You provide examples so that the model understands. It is able to understand the pattern about what exactly is what you are expecting. So the examples are especially valuable when the desired style or the judgment is difficult to explain. And that's why it becomes important so that the model understands. So I'll give you an example of the research project in our in my research group, what we do is, which is ethical decision making. So where we provide, given this scenario, tell me whether this scenario is ethically right or ethically wrong. And the example where we provide this context is basically we provide the scenario and we ask. We also provide that the human has given 0, saying that it is not it is ethically right, and if it is 1, it is morally ethically wrong. So the model understands that this is the example, and I should be able to behave in that particular manner. So that's the first part. So this particular slide you will give can help you understand why this RCFE plays an important role. So you will see over here there is an R, which stands for the role and task, where we are saying that you are a technical communication specialist. I'm providing what exactly is the task, which is rewriting. The context that I'm providing is that, okay, so the simplified explanation will be used in the introductory, this artificial intelligence course, and you have to preserve the meaning and you have to replace any technical argument, and you do not introduce any kind of information. And if you are unclear about whatever information, just say uncertain rather than just guessing. And this is a kind of a source text which I will be providing you. Then I'm giving the format. I'm asking the return the response in the form of 40 to 60 words. So the model understands that I'm expecting a bunch of text, but it should be limited to 40 to 60 words. And the examples that I'm providing you, this is the example input and this is the example output. So this way the model understands that this is what I'm expecting in the end. So that is the reason it is important that you provide all of these 4 things. But the question that you will be having, are all of these 4 things important? Well, it depends upon the use case that you are interacting with the large language model. Sometimes it is important, sometimes it is not. Somehow this is showing me these beautiful wrong colors, and I don't know why it is showing me. So let me get rid of all of this. I don't know why this just happened. Clear all drawings. Okay, good. So the next question that generally comes to the people or the user is that how many examples I should be providing. And you might have heard this term called zero shot and few shot. Zero shot stands for that I will not be providing any kind of an example. It is just on the basis of instruction. And few shot is also termed as in-context learning, where you provide a set of worked example and the model infers the desired pattern from these demonstrations without any updates to its weights. And few shot can stabilize the tone. It can also understand the edge cases. With respect to zero shot, the problem is that they are they are fast to write, and they often work well for common, clearly defined tasks that, okay, summarize this paragraph, extract this relevant information. But the problem with zero shot is variability. So even when the task is understood, the model may produce different length, tones, its structure or interpretation across different runs. And a zero shot instruction is like classify this comment, and it can classify with a bunch of text being produced, or it can classify with a single word. When you provide different examples, the large language model understand, okay, this is the kind of an example I'm trying to understand. However, in this case, there is, when you provide context tokens, when you provide a lot of examples, the model tries to just understand that particular topic. And that is the reason when you are providing few short example, it is always better that if you are trying to learn the sentiment of an emotion, then you provide an example of a positive emotion and also a negative emotion. Versus if you just provide positive, then the model starts giving you always positive label rather than a negative label. So that is important rule, that whenever you provide different examples, provide the perfect set of both positive as well as the negative example. if the task is a classification process. Now, moving towards the next part, which is how these few short examples should be given. So remember these five important things that whenever you are giving these examples, one is coverage. That is that the examples that you are providing should represent the variety you expect in the real inputs. It should include different topics, different input lengths, levels of difficulty, even include edge cases. The second one important thing is consistency. So every demonstration that you are providing should use the exact structure. If you use different structure, once again, the model tries to not understand what you are actually expecting. The third is that order effect. So here the order effect is that if you are giving the positive example first and the negative example second, the large language model tries to pick up the latest example, the later example that you are providing rather than the positive examples that if you are providing in the first case. So order does play an important role. So what I'm trying to say is that it doesn't mean that if you have given positive example first and negative example second, it would always be negative example output. But let's suppose if you are giving 32 examples, because there's not a magical number that I should be giving you 4 examples, 8 examples, or whatnot. What I'm trying to say is that when you are designing this, give equal set of both positive and negative. If it is positive and negative, have positive, negative, rather than just bunch of positive together and bunch of negatives together. The next one is label balance. Once again, as I mentioned, that if you are doing any classification task, and if 5 demonstrations are labeled as safe and only one as unsafe, then in that case, the distribution will influence that the model will always pick up the label which is safe rather than picking the second example, which is unsafe. And lastly, always provide examples, which is prioritizing quality rather than quantity. 3 sharp examples should be much better than you provide unnecessary multiple examples. Very similar to in real life and real situations as well, that always quality plays an important role in comparison to providing quantity of examples. Now, the next part I wanted to focus is that how exactly we help models to produce an output or reason better. And one important thing is that people use this specific term, which is chain of thought. So a chain of thought is a very good example if you want the large language model or generative AI in the sense to provide a kind of a reasoning. So you ask the LLM, large language model, give me step by step what exactly you are feeling, what exactly it is you are deciding on this specific example, how exactly you are reaching to this specific conclusion. So that is an important part where the models can understand and provide you the reasoning capability. Coconut model is one of the model, and if you want to understand how exactly the model learns or reason, is one example. I will share that specific link in the slides as well as in Canvas for this. The second one is decomposition. So decomposition, what it means is that rather than asking a much more generalizable task, okay, produce this, instead of performing or asking large language model to produce everything at once, you divide the task into smaller stages. So for example, you tell large language model, okay, first extract the relevant facts from the document, then transform those facts into a summary, and finally verify that the summary contains unsupported claims. So the models does provide much better reason in comparison to if you just, okay, perform this task completely. So decomposition, what it allows is it also improves observability. So if the final answer is wrong, we can inspect where exactly the model start giving you wrong information, whether it was in the extraction step or it was in the transformation step or whether it was in the verification step. So decomposition does play an important role. A very related technique is self-consistency or verification. So we can generate multiple candidate reasoning paths and compare them, or use a second pass that acts as a critique. So it's a very similar to in our brain, there is this phenomena of actor and critique, where actors behave and there is a critique model which critique checks whether the first answer follows the source and satisfies the requested formats or avoids mission. So it is kind of giving a kind of a reinforcement. Okay, I believe that this is right, this is wrong. So kind of an critiquing option. So you have multiple reasoning paths and you pick the most important path where the critique is the one which will pick the best answer among all these reasoning paths. So I'll provide that specific paper if you would like to read. So now, since we have understood how exactly the model can reason well, how exactly we can control the output as well. So structure and constraints are very important part of the output control. So do not simply just ask for, okay, I'm asking a table, specify the column names. Do not simply request, okay, I'm requesting a JSON file. Define what are the keys, value types, allowed values. So the examples, the more example or the more things that you will provide to the large language model, they will understand this is what I'm expecting. Use delimiters. So delimiters help separate instruction from data. Triple backticks, XML style tags, or clearly labeled section tell the model where the source material begins and where it ends. Like in the example that I was showcasing, I had these three codes. This was basically a kind of a delimiter that the model was showing. Next one is the length and the style. So when you, instead of asking, make it short, specify a range of, okay, produce 35 to 60 word. And instead of saying, just make it simple, I say that identified, you can tell this is what my audience looks like and this is what the reading level is. Produce a response where they can understand this in layman language. So providing the length as well as the style does help the large language model how you are expecting. And next one is, every time when you are asking the large language model to produce an output, check the machine checkable output. So if the result can be parsed, it can be validated. So a program can check whether the required keys exist, whether labels belong to an allowed set, whether the number of rows are correct, or whether the output exceeds the word limit. Lastly, but not the least, some APIs can enforce JSON function schemes. So even then, prompt design still matters because a valid structure does not guarantee any good content. The model can produce syntactically valid JSON that is incomplete, inaccurate, or purely the reason. So that is the reason always follow these different kinds of tactics if you are designing and if you are expecting the output of the model to behave in a particular manner. Once again, all of this falls under our objective that we are focusing, which is the first objective, which is how to design or construct our prompts in a better manner. Next thing I wanted to focus is context management. What exactly? It's a kind of a model's finite working memory for a single instruction, and it should hold instructions. It should hold examples, documents, prior conversation, and the model's own generated output. So context window, whenever there is a huge amount of the same window is being used again and again for multiple times, you are interacting with the user, model tries to hallucinate and it produces the output which is hallucinating from this huge humongous amount of data. In this context, position also plays an important role because in long context, models may use information at the beginning and end more reliably than the information which is buried in the middle somewhere. And this behavior is often termed as lost in the middle. And the practical response is to place critical instructions near the beginning and restate the final question. always near the end. That is important role when the positioning of where exactly you are introducing the task and everything should plays an important role. As I mentioned, when it is a very long context, the long conversation can always drift to a specific thing, what exactly you were asking in the start versus what exactly the model is producing in the end. It can just be a totally different thing. So as the chat grows, earlier requirements may become less influential or maybe summarized imperfectly, and the output begins to deviate and it will just produce wrong information. More context is not always better. Irrelevant material may distract the model. So it's like people say that, okay, the more context I'm providing, it will be better behave well, which is not true. So these are important things that you should remember that when you are providing these different kinds of context. Last but not the least, I wanted to cover that how exactly there are these four important things that you should remember. So language models generate output by selecting tokens from a probability distribution. So sampling parameters does influence the how the model selects the output. So these are the four important things that you should remember. First is the temperature parameter. So temperature rescales the token probability. So if you have bunch of these probabilistic numbers, it will always the low temperature value. So the temperature value, whatever you are feeding in, if you are picking a zero value, it will make high probability token more dominant and the output tends to be more deterministic and conservative versus a higher temperature value closer to 1, then it increases more diversity. So the question that you would be having, then when exactly I should be using a 0 temperature versus a 1 temperature? So for extraction, evaluation, reproducibility, use a value always near to 0. For brainstorming to come up with better research ideas, or when you're just exploring in this or baking a cake, you want to be just more creative, coming up with a new company idea, try to use much more higher value of temperature because it includes it can pick random values rather than just picking up the most dominant value. So that is one thing. The next thing which plays an important role is top P, which is also called as nucleus sampling. So nucleus sampling restrict the generation to the smallest set of tokens whose cumulative probability reaches P. Temperature and top P always affect diversity. So it is always usually better not to tune both aggressively at the same time. So top P is another nucleus sampling, which is plays an important role. The next one is max tokens. Max tokens plays a hard cap on the output length. So if the cap is too small, the model may stop in the middle of a table or a JSON object because it's you have put the maximum token size at that particular value. And that can appear to be a formatting failure, even though the real cause is just a truncation. So that is another thing. Stop sequence are another important thing, which is these are the strings that terminate generation. They are useful when a model, when an output must remain inside a delimiter or when multiple records are being generated in a predictable format. So the key lesson is that the prompt alone does not guarantee identical output. For reproducibility, record the model, prompt, temperature, top P, token limit, and any other relevant settings in your practice log. So with this, I would nearly end my lecture by saying that by far what we covered is that, okay, its prompt iteration is a very experimental loop. You write, you run, you inspect, you diagnose and revise continuously. So the first step is to write an initial prompt containing the role, context, format, RCFE that I discussed. The second step is to run that prompt on a fixed test set using fixed generations setting. Um, The second step is to run that. The third step is inspection. Evaluate the models against explicit criteria such as factual accuracy, format compliance. And the next one is diagnose. Did the model ignore the field? Did it hallucinate information? Did it exceed the length limit? Did it use the wrong label? Did it drift away from the requested audience? And finally, is that you revise much more meaningful, and you run and test your case again and again. So that is one example I wanted to showcase. With this, I would like to end the lecture, but this is the thing which I will be posting as well. This is a very simple thing which gives you the demonstration of zero shot, few shot, as well as structured prompt. So this is just for, it's an optional exercise that you are saying that there is the source text. You ask, okay, produce what is the length of this source text. Then you give a prompt saying, okay, simplify this particular paragraph for a general audience. So it produces. The second one is that you provide certain few examples, and then you rewrite and you again ask, okay, can you now refine this output again? So you will see how exactly the output vary when there was no example versus when you gave a few set of example. Then the next thing is that you provide R, C, F, and E, as I mentioned, role, task, context, format, and example. In that case, will the model starts producing different output in comparison to just providing a zero shot or few shot example? And once you have done all of this, then there is this particular table where you compare zero shot, few shot, and structure, how exactly the output words vary, how much it compressed, whether it was within the limit, it included certain jargon, and whether it produced the output which is machine checkable. So this is a quick thing I will be posting. So feel free to work around on this. With this, I would end my lecture. Thank you, everyone.